Today we're going to be talking about factors and prime factorization. And this goes along with anything with a 3 in your notes packet. All right, so first some vocabulary words that we need to know. If we're talking about a factor, that means what two numbers am I multiplying to get a product. So a number multiplied by another number. Composite number means I have 3 or more factors. A prime number means I have exactly 2 factors. And by the end of today, we're going to be working on prime factorization, which means what series of prime numbers do I multiply together to give me the answer. So let's just take a look at different ways that we can find factors. So I can make a list of factors. So, whoops. If I'm trying to find factors for 24, 1 times 24, then I can think about 2 times what? So 2 times 12. 3 times what? 3 times 8. 4 times what? 4 times 6. 5 doesn't work, and then 6. But look, I've already used 6. So when I start to repeat factors, I stop. So the factors of 24 are, then I like to write them out in numerical order. So I've got 1 and 24, 2 and 12, 3 and 8, 4 and 6. All right, so this is one way that I can make a list of factors. The other thing we're going to work on here is prime and composite numbers. So how do I know if 61 is a prime or a composite number? Well, 61, if I think back to what we did a couple days ago with divisibility rules, I can see that I don't think any of my tricks are going to work. It's a 1, so that doesn't work for 2. 6 plus 1 is 7, so that doesn't work for 3 or 9, and that automatically takes 6 out of the equation. It's not 5 and it's not 10, so that means that 61 has to be a prime number. It only has 2 factors, 1 and 61. 65 I automatically know is going to be divisible by 5. So since I know that it has more than 2 factors. So 65 is composite. Okay, so this is how I can use my divisibility rules to help me figure out, is a number going to be prime or composite? All right, now we're going to find the prime factorization of a number. So we're going to find the prime factorization of 90. So I want to know what's the series of prime numbers that I can get to get to 90. We're going to use a factor tree. I think this is probably the method that most of us use. I think it's the easiest. So that's how we're going to rack this out. So I need to know what times what gives me 90. Well, I know since it has a 0 at the end, it's going to be 10 times something. So 10 times 9 gives me 90. Then I need to break apart 10. 2 and 5. Is 2 and 5, are 2 and 5 prime numbers? That they are. Now I'm going to break apart 9. I get 3 and 3. Can 3 be divided anymore? It cannot. So when I get, once I find my prime numbers that can't be divided anymore, I circle or highlight them. So now I'm going to write out this and I'm going to use exponents. So my prime factorization is 2 times 5 times 3 squared. All right. And you're asking, Mrs. Hook, why do we need to know prime factorization? Well, prime factorization is useful when we have to find the greatest common factor and the least common multiple of sets of numbers. So we're going to practice prime factorization in isolation so that when we get to doing this, it'll be really easy for us. Okay? Now I have a couple of problems that I'd like for you to try on your own. So you're going to tell me, is 39, 47, and 63, are those prime or composite numbers? And you have to tell me why. And then you're also going to find the prime factorization for 144. So go ahead and hit pause on your video and I'll be back with answers. All right, let's take a look to see what we got about the number for 39. So if I just use my divisibility trick, I can say 9 plus 3 is 12. 12 is definitely divisible by 3, so I know that it has to be a composite number. 3 times 13 is 39. So I've got 4 factors, which makes me composite. 47 off the top of my head. I'm not getting anything with my divisibility rules to match up. 7 plus 4 is 11. 7's an odd number. So I know that 47 has to be a prime number, which means the only two factors are 1 in itself. 63 I know is going to be divisible by 9 and by 3. So I have a plethora of numbers that 63 is divisible by. So I know that it's a composite number. Now if I take a look at the prime factorization for 144, I'm going to come up with 2 to the 4th power times 3 to the 2nd power. How did I get that? Well, I know that 12 times 12, and it doesn't matter the route that you take. I know that 12 times 12 is 144. So I use those two numbers. Then I broke 12 apart. 2 times 6. 2 is my prime number. 6 can be divided into 2 and into 3. For this 12, notice I took a different route. I did 3 times 4. So 3 was my first prime number that I got. And then 4 breaks down into 2 and 2. So it doesn't matter how you decide to break up the numbers, because eventually your prime numbers will all be down here at the bottom. So 2 to the 4th power gives me, where's my pen? 2 to the 4th power will give me 16. 3 squared gives me 9. So when I do 16 times 9, I get 144. And this is the end with factors and prime factorization.